Okay, hi everybody. Welcome to the OpenStack Charms project update. I'm James Page, and I'm going to be the PTL for the train cycle.
Yeah, I'm Frode Nordahl. I was PTL for the slide cycle. And
okay,
yeah,
let's kick off. So I thought we'd probably start with a quick 101 on what the OpenStack Charms actually are. So quick show of hands, who's using OpenStack Charms today? 4, excellent. So we'll just do a little bit of history on the OpenStack Charms. So OpenStack Charms are a set of deployment tooling for deploying OpenStack, specifically on Ubuntu. We're currently single operating system support. We've been around for a long time, so the first commits in our Git repos date back to 2011, so almost the dawn of OpenStack, but not quite. We cover most of the major projects within OpenStack, all of the core infrastructure as a service projects, as well as some of the more peripheral stuff around telemetry, DNS, secrets, orchestration, object storage. And just most recently, we've also introduced load balancing in the form of Octavia and Masakari, which Frode will talk about shortly. We do have a few gaps. We've got some grays there. They're charms which are available, but we consider not complete, not production ready yet, in a very much a early beta, early alpha status still. Okay, so the OpenStack Charms project just forms part of the deployment tooling that you need to put together an OpenStack cloud using the Charms. So we've got like 4 other supporting technologies we're going to, 3 or 4 supporting technologies we're going to talk about. So the first one is Juju. So quick show of hands, who's heard of Juju? Excellent. Okay, so Juju is an application modeling tool. It's model-driven and kind of drives a reusable open source operations set of thinking. It really talks about applications, machines, relations between applications. It also models networking and storage. And those are all things that we make use of in the OpenStack Charms. Juju basically deploys the Charms for us. So if you think of other technologies, the Charms would be like an Ansible playbook to Ansible, or Puppet modules to Puppet. So the Charms are what Juju actually deploys. So again, Charms are the kind of encapsulation of the operational knowledge of each part of the application that forms a model. So how it's installed, how it's configured, how it relates to other applications within the model. So how Keystone relates to Glance and Cinder and Nova and Neutron, for example. How that application is upgraded and updated, how it's scaled out, so how we add more capacity, how we add high availability. These are all things that are encapsulated in the Charms. So as I said, for the OpenStack Charms, we've been deploying OpenStack since 2011. We cover all of the core infrastructure as a service services, telemetry orchestration. We have high availability and scale out as standard in all of our services. We support series upgrades between OpenStack series, and we pride ourselves in having our deployment tooling up to date with the most recent OpenStack release within 2 weeks of the OpenStack release. We're not prescriptive in terms of how you deploy your cloud. As a team, we have opinions about the best way to deploy OpenStack in a kind of hyper-converged model, using containers for some of the control plane services. But ultimately, you are free to do to make the architectural choices you want to. So if you want to have your compute and storage on completely separate infrastructure, that's entirely supportable. If you want to have them converged, again, that's something the Charms can support. So one of the other tools that we make use of in the OpenStack Charms project is a project called Maz. This is an open source bare metal automation tool. It's been around for a while. And it's providing automated provisioning of physical machines within a data center. In terms of how that fits into the picture, Juju is used to deploy the Charms, but Juju also talks to Maz in terms of getting physical machine resources to then deploy the Charms onto and to place containers on. It has a kind of nice WebI and a REST API and provides IP address management, storage configuration, network configuration, that type of stuff for the servers being used for the deployment. And the kind of final technology I wanted to touch on was LexD. So LXD provides us with what's called machine containers. So whereas Docker is an application container framework in that each container contains a single process, LXD container is a machine container, and then it has everything from init downwards. So it runs systemd, its own systemd, its own rsyslog, its own SSH. So it looks like a full physical machine to whatever's being deployed on it. So we can take a charm that will work as well on a virtual machine, on physical hardware, or in a LXD container, and we can write it in exactly the same way, use the same terminal, all three of those specific use cases. So what LXD allows us to do in the context of an OpenStack charms deployment is it allows us to pack all the control plane services onto the same hardware that's hosting hypervisors or storage. So the Nova control plane, the Neutron control plane, the Glance control plane can all sit in containers on the same hardware. And we do other things like we deploy Ceph as part of the OpenStack charms project. And we place the Ceph monitors in containers across the infrastructure. So that we can place those alongside the Ceph OSDs that are actually running on the underlying bare metal. Okay, so enough about what the OpenStack charms is. I'm going to hand you over to Frodo now, who's going to give you a bit of an update on what we just delivered in the 1904 OpenStack Stein release.
Yeah, so the last pulse cycle, we've been preparing the OpenStack Stein support for us. We tend to release the charms just after the upstream release, and each charm release that is paired with an OpenStack release contains support for the latest upstream release. We also have a preview for support for Masakari. Masakari is automated instance recovery. And its goal is to detect when a hypervisor goes down and try to move your instances over to a separate hypervisor to restore the service that is running on those hypervisors. We also did a couple of points on disaster recovery. One is extending the Ceph Radius Gateway charm to support multi-site replication. What that does is you can have a Ceph Radius Gateway on 2 distant data centers and have the data moved across for the object storage. The block storage partner to that is the Ceph RBD mirror. That's a new charm which takes care of creating pools on a remote Ceph cluster and configuring the RBD mirroring. So when you have that enabled, all the pools and images you create on your one data center is automatically mirrored over to the second one. Bear in mind, you have to do additional steps to actually, fail over an entire cloud. You need to move the databases and stuff like that. And that's not part of this. This is just the Ceph part. Other things we've done is improved support for deployment on offline sites. A lot of our tooling is dependent on internet access to download resources and things like that. But often some environments have, they're air-gapped basically, where we basically set in a proxy on the site to be able to service the cloud without internet access. And we've been doing some improvements there. We also have a preview for Keystone Federation with SAML Melon. That will basically give you, if you have a SAML IDP in your network already, you can use that to log on to your cloud without having to recreate users and things like that.
Yeah, and that's fully integrated into the Horizon dashboard, so you could basically get a single sign-on for your OpenStack cloud through Horizon.
Yep. And we have done some work on Cinder backend templates. There's a lot of storage vendors out there. I'm not going to name anyone, but we constantly go into engagement, and people want to have the storage, the vendor they're already using, supported. So we created a framework where you can basically charm the driver for that storage vendor very easily, as easy as possible.
Yeah, I think it's fair to say that across every storage vendor, 80% of the charm is the same So we've managed to extract those out into a generic template. So you only have to do the last 10, 15% last mile, which is storage vendor specific in terms of work now.
And we've done some work on documentation for the PCI pass-through and GPU support. We have had that support for ages, but we found that we didn't have any examples of documentation up there. So we did that to show off how you can do it. And we also have a preview of Neutron DDR plus SNAT. That means that you can deploy a cloud without having the Neutron gateway at all by enabling the SNAT feature of DDR on all the compute hosts. So that's part of our, it's an experiment in creating a clouds without having separate nodes for the gateway.
That's going to work really well where we're talking about smaller private cloud deployments, where we're able to pipe the external networking that's going to be used to access the cloud down to every hypervisor. So in larger cloud deployments where that might be more challenging, it's probably still going to be appropriate to use network nodes in the form of the Neutron Gateway application. But for smaller private cloud deployments where that is possible, then this provides a much more consolidated converged route to providing the north-south traffic in and out of your cloud and to your workloads.
Yeah. And then there's back to you, James.
Okay, right. So what are we doing? What are we doing next cycle? Well, that's a really good question because we haven't actually agreed all of this yet because the PTG is not till Thursday when we're going to talk about some of this stuff. So, if you have any opinion, please provide feedback. We've got some potential work that we're going to do around further containerization of services. So, looking how far we can push things in terms of putting things into LXD containers. So. Our Neutron Gateway charm, which provides a network node personality within the cloud, is going to see whether we can get that into a container potentially. The same with Nova Compute and Nova LXD for the LXD hypervisor. That's kind of a maybe at the moment. The DVR SNAP feature that we just talked about removes some of the need for that requirement in terms of getting everything converged via containers because we're now able to converge more effectively actually using OpenStack itself. So probably be some conversation around that as to whether we're going to need to do that or not. We've got a few kind of improvements to do on DVR SNAT, a bit more polish, and a lot more testing. We've got it in proof of concept in a couple of test environments, but we really want to put that through the mill before we put the rubber stamp on production ready on that one. This cycle with the Ceph Rados Gateway multi-site replication support, we kind of had a bit of a gap in our testing framework in that we wanted to be able to test this in the way we think users are going to use it. And they're going to have probably maybe even two separate controllers with two separate models with each Ceph deployment in it with Rados Gateway. And then they're going to use something called a feature of Juju called cross-model relations, which allows us to link those things between two controllers and two models and do the configuration remotely. However, our current testing framework doesn't actually have support for multi-model testing. It makes the assumption that everything you're testing is in a single model. So we want to do some feature work there to enable us to test things more realistically as part of our functional testing gate that we have for every commit that goes through. We've got some polish to do on our Nova LXD support. So the majority of clouds that go out the door are based on libvirt and KVM, so they're using a full virtualization stack. However, in the OpenStack channels, we also have support for the Nova LXD driver, which uses LXD machine containers that I was talking about earlier in place of libvirt KVM containers. So they're lighter weight, they're less overhead, so typically the latency and performance figures around them are really low and really high, respectively. But we've got a bit of work to do. The LXD project has moved their primary distribution semantic from DEBs to snaps, which is a different packaging format. So we need to got some catch up to do there in the charm. And there's some work done prior cycle on Nova LXD to make it work with the snap as well. And we're going to rename our LXD charm to Nova LXD, so it's clear that it's actually an OpenStack thing rather than LXD more generally, leaving that namespace open to anybody who'd like to actually write a LXD charm themselves. Oven is an SDN that we've been talking about charming for actually quite a while now. We've had fairly regular conversations with the Open vSwitch team who are producing that SDN about when it's ready. And I think the feel is now that with the last two releases, that the final kind of pieces have fallen into place within Oven itself in terms of high availability around the actual SDN controller and scalability of incremental updates to hypervisor edges. So I think we might get that on roadmap this cycle. I just had a really interesting conversation with the guys from Cloudbase because they also need this for a solution they're working on. We may get a really interesting collaboration going on there to get that in for the train cycle. We've got some work that's currently in flight around Swift global clusters. So in a similar way to we're doing cross-site replication in Rados Gateway as of today, this introduces the same feature but for Swift. So having geo clusters and replication between them, so for DR purposes. And then a couple of improvements into the Cinder backup stack we've got. We already support Cinder backup with a separate Ceph cluster, but we're also looking to provide support for backing up to Swift and for backing up to Google Cloud Storage as part of our roadmap for the next 6 months. Anything else? Oh, and OpenStack train support. I forgot to put that on.
Yeah.
Kind of implied. We always have it, so that should come through alongside the rest of these features.
Yeah, I think that covers it.
Okay.
And we are an open source project, so fixes and commits are welcome. This is how we get in touch with us. We are on OpenStack Swarms on the Freenode. We have weekly meetings, alternating time zone friendly slot. Except it's almost at lunchtime at home, but I can survive. That should actually be the OpenStack discuss list, so we need to update that.
Sorry, Slidecraft. Apologies.
And we have some documentation, both a charm guide and a deployment guide.
Yeah, so the charm guide is really good for if you want to get involved in development, because it takes you through how to make a commit, how a charm's structured, how to write a new charm, that type of stuff. Whereas the deployment guide is more operator focused in how to use the charms, how to get started with MAS, what bundles are, what charms are, what the various optional features of OpenStack charms are, and how to use them. So things like encryption at rest, certificate management, load balancing, they're kind of add-ons on top of the core OpenStack base bundle that we have for deploying OpenStack using the OpenStack charms.
And the things we need is doing a review, advice on things, documentation, bug fixes, and just come talk to us. And that brings us to questions. Do we have any?
Okay, I don't think there's any questions. So
crystal clear, I guess.
Thank you for your time and enjoy the rest of the summit.